Okay, find the area of the shaded region. Well, the area of the shaded region is going to be first the area of the entire circle. What is the area of the entire circle? The area of the entire circle, area equals pi times the radius squared, and the radius is 12, so 144 pi meters squared is the entire area of the entire circle. Now, what we need to do is we need to say, okay, uh, we need to now find 1/6 of that, which would be this whole area, okay, and subtract away from that the area of the circle, and we will find this section. And that number is what we are going to subtract away from the entire area of the circle, okay? So we need to figure out what's 1/6 of this area. So what's 1/6 of that? I say 1/6 because that's 60 degrees, and 60 degrees is a sixth of it. So we say, okay, that 144 pi meters squared divided by 6 will be the area of this sector right here, okay? And we're going to take that and we're going to subtract away from it the area of that triangle. Well, we have a triangle with an area with a 60-degree angle and 12-meter sides. So we say, I'm going to draw that triangle here, okay? And if the angle here is 60, then when we drop this altitude down, we get a 30-degree angle here. Okay, if this side is 12, then this portion is 6, and this is then, the height is 6 root 3 because of our 30, 60, 90 triangle, 6 root 3. Okay, if you are unfamiliar with why that height right here is 6 root 3, then you are not 100% familiar with 30, 60, 90 right triangles and their special relationships in their sides. But the special relationship is that whatever you know, and we're looking at this right-hand side of the triangle, whatever you know this is that amount times root 3. So we've got a base of 12, a height of 6 root 3, and so the area of that triangle, and by the way, this, again, this is this red sector, and we're going to take away the area of the triangle, and the area of the triangle formula is 1/2 base. The base is 12, equilateral triangle, times the height, and the height is 6 root 3. Okay? So what do we get when we do that? We take the area of this entire red sector, which is a sixth of the entire the circle's area, and we take away the area of the triangle. And when we calculate this out, we'd say 144, let's see, 72, gosh, 24 pi meters squared is what this simplifies to, minus half of 12 is 6, and 6 times 6 root 3 is 36 root 3 meters squared. That's what it is. And then what we have to do is we need to subtract that away from 144, because what we're doing is we're saying this portion of it, well, this portion of it calculated this red sector. We subtracted away the triangles portion, so what we were left with is this amount right here. And that's the only thing that we need to take away from the original area. So we can write 144 pi meters squared minus, and I have to put it in parentheses because they were saying minus all of this, 24 pi meters squared minus 36 root 3 meters squared. Now watch what happens. This subtraction here, this negates both of these signs, so this becomes minus that, and this becomes plus. Minus and negative is plus. So you get then 144 pi meters squared minus 24 pi meters squared plus 36 root 3 meters squared. And this portion can be simplified. You can do 144 pi minus 24 pi. That's 120 pi. So what you get is 120 pi. We'll put the meter squared at the end. 120 pi plus 36 root 3, that number of meters squared. And where do we see that? We see that in answer A. Okay. You might need to, excuse me, review all of this, but this is the area of the entire circle. Okay. This is the area of the red sector. And this is the area of the triangle and so by doing this portion right here, you find this, which is, and I'll label that as well, area of unshaded portion. Okay, so then doing the area of the entire circle, this right here, minus the area of the unshaded portion, this right here, and then distribute that negative through and combine the like terms here to simplify, because they're both in terms of pi, you get the area of the shaded portion. That's a cool problem. Hope that made sense to you.